Okay, I wanted to demonstrate a couple of quick features that I've implemented in this sort of little sample toy game that you can use in your final project in the class that I'm teaching, the Intro to Game Programming class here at RPI. And hopefully maybe someone else will find these sort of useful for some of the things that you're doing. We're using Unity here, and our final project is a platformer, side-scroller sort of thing. And so I wanted to demonstrate the use of let's see, I have a surface effector, I have coroutines, I'm using a little bit of class inheritance, I've got some basic motion and some delegates and events, all sorts of fun stuff. So let's get on with it. All right, demonstrate the game first off. This is my little Shaggy Escapes the Zombies game. So this is my little character Shaggy here, and he can run around, and he's not really under much threat from the zombies. There are two types of zombies. There are the boring zombies that just sit there and don't do much of anything, and then there are these red kind of randomly moving zombies. They kind of move around and just kind of push things a little bit. And you'll also notice that there is this thing over here, which is an effector that we can't quite get past unless we jump over it, which we can. So we can jump over it, and if we touch this button, we can change the direction of the effector, and we can still jump over it and go in that direction. And there are, let's see, my little Shaggy boy here has one attack that he can do. He has this sort of shout attack, and you won't actually be able to hear him, but I'm going to hit the Q key, and any zombie that is within a distance of like 3, I guess, it will hear that, and it will explode. So I'll hit it again here, Q, oh, this guy, and if there were multiple zombies, they would all hear it, and they would all explode. And then if Shaggy is not careful, and he falls on these spikes, he will shrink and then explode. So let's talk about how all that was done. Now there's, let's see. Okay, so the zombies, there are 2 prefab zombies. And let's go into our prefab director here. There's a normal zombie, which just has the base zombie script on it. And if you find it, let's see. Yep, here's the zombie script, which also has the animator prefab explosion on it. And it has a radius for how far zombies can hear. Okay, and then the other zombie is the moving zombie, and it has the moving zombie script on it. That script is derived from the other zombie script. So you see it has similar, the boom, but it has hearing radius and also speed because it has that jerky motion that it does. Okay, so those are the 2 prefabs that we have. Then in scripts, we have a couple of scripts. We have the moving zombie script. We have the normal zombie script. We have the player script. And a switcher script, which is the thing that if you hit this button, it does some things to this switch. We have this sort of switchy object, which is the switch itself. And then we have this mover, which is our little graphic. And the graphic also has the surface effector and its collider on it. Then we have the little signal thing at top here, which just sort of indicates which direction the surface effector is moving in. So, all right, then we have just a bunch of prefabs that are all thrown in here. The cool thing, you'll notice that like multiple zombies can blow up, even though they're all kind of placed on here. I'm not managing them through sort of a list. I'm not actually spawning zombies in the play or anything like that. I'm placing them in the scene. So in order for them to all get registered or to see kind of what's going on, they actually use an event. So they're all listening for this on-shout event that our Shaggy character can sort of do here. So let's go over to C++. No, not C++. Boy, I was doing Unreal today. We're in C# land here. We can see our scripts. So first, let's look at the player script. So here's player CS. And you'll see it's pretty straightforward. We have a couple of serialized fields here. The force that he jumps up with when the space key or the up axis is, the jump axis is activated. The speed that he can generally move with, and here's our prefab to our boom explosion that happens once he dies. And there's a couple of things in here. Now, the important part here is our delegate, which is our event. and that's going to be the handler for on-player shout. Right? So on-player shout, everyone can listen for the shout and then make a decision whether they want to do some action based on the shout. Okay, so we set up a delegate, void player handler, which doesn't take any arguments and just has a void. It returns void, and we set up a public static event based on that delegate called onPlayer shout. Nothing goes on in this start routine. We have a target, which is just kind of a vector 2 set to 0 for starters. We'll see where that is later. And then in here, okay, void update. If we press Q, here's where we activate the shout. Now, the first thing we do is we see, okay, is anything registered? Is anything listening to our broadcast? And if not, we don't bother to call it because we don't want to dereference null. If we're using a more recent version of C#, we could use the conditional null structure to do that. But here we're just going to say onPlayer shout does not equal null. If not, broadcast the onPlayer shout event to everybody who's listening. We also have our basic straightforward if input get button down jump. We set jump equals true. We set a little flag there, and we also collect the value of the horizontal axis, and we put that into our x value scaled by speed of our target vector, and that target vector is going to be the thing that we use to add force in a certain direction to our player. All right, so here's where that stuff actually happens in fixed update, because since these things are physics-based, we want to do them in fixed update so they're nice and smooth. So if jump, we get the rigid body 2D component. We probably should set that up ahead of time and not do get component every time, but for now, let's leave it at that. And we just say, okay, transform.up, which is the up direction. We multiply it by force, so that's going to push them in the up direction. Then we set jump equals false back to 0 again. We're back to false, so that we're not jumping. Notice I'm not doing is grounded and all that. I'm just shortcutting right now. But other important part, okay, if target magnitude, so if we have a value of our target according to our joystick that's greater than 0.1, meaning, yep, okay, the user is pressing A and D or the left and right arrows or using a joystick, we want to move in one direction or the other. So what we do is we get the current velocity, we set the Y component of that to 0, and then we say, okay, well, if the x is less than 0.05, that must mean we want to flip the x of the sprite, which is our little shaggy little boy sprite. He's going to move in the left direction or the right direction. So just flipping the sprite image depending on what the direction of the target x is. And last but not least, we do a get component. This is where we actually move. We say add force, and the force is just an impulse, so it's an immediate action, and we basically say, all right, target minus current velocity, so that gives us the difference. So we're currently moving at a certain speed, but we want to be moving at another speed, so we take the difference of the two. Since it's a vector, we just normalize it so that there's no y component. I guess this is extra because this is all set to 0 anyway, but okay. We multiply it by speed, and we set that to do what it's going to do. So that's going to be adding a force that is going to be basically get us to the speed that is indicated by the joystick. Oh, did we add it twice? We did, didn't we? Wow. Okay, we normalized it there. Whoops, there's a bug from earlier today. Multiplied it by speed to get that, but then we normalize it and multiply it by speed to get that. That's a bug. So that's like multiplying it, then dividing it, basically setting it to 1, and then multiplying it again. Whoops, sorry. All right. Then we have a simple collision to say, okay, since we have, let's look at this in the game. I should have pointed this out. The way that the scene is constructed is that you have a couple of different tile maps in here. We have a grid that has platforms on it. You can see in our scene here, there are platforms. And there's our background layer, which really doesn't have much of anything on it at the moment. And then we have our hazards layer, which has these spikes in it. And the spikes, the collider, or that hazards layer, it is tagged as being deadly. Okay, so if we collide with the hazards layer, which is tagged deadly, we can cause our little character to die, which is exactly what goes on here. So there's a tile map collider set as a trigger, and we enter that, and then it says if collision.compare tag deadly, start coroutine, shrink, because we want him to gradually shrink away to nothing, and when he hits 0, he goes poof, and he's gone. But before he does, he also shouts. He's got this death shout to kind of destroy any zombies that are within hearing range, I guess. So here's shrink. It's set up as, we have a coroutine, and it uses IEnumerator shrink to be declared, just like good coroutines do. And we even use a bit of interpolation here. So this is kind of the most basic kind. We're going over the course of 1 second. So we're saying for float I equals 0 to I is less than 1 for 1 second. We go in increments of a 20th of a second, 0.05. And we just scale them down. We start off at one end of the spectrum. One end of our interpolation is 1. So, and the other end of the spectrum, the other end of the interpolation is 0. So we're going to interpolate between 1 and 0 over the course of 1 second. That'll give us our new local scale value. So that's how he scales all the way down. And then we yield in this loop, which is also good practice. That's basically what the coroutine needs to do so that it doesn't lock up. So this is going to go to sleep, wait 0.05, a 20th of a second, then come back and execute again. Runs through that loop 20 times, basically. And then finally, as he's about to die, he checks and he says, okay, let me shout out and try to destroy some zombies. And then, so he calls that broadcast event. And then he decides, okay, we're going to instantiate our boom, our explosion, and we set it up so that it will destroy itself in 2 seconds, kind of clean up after itself. And last but not least, we destroy the player. Maybe we don't want to do, but that's just what we did. This is a quick, short one. All right, other scripts. We have the basic zombie script. The basic zombie script, all it does is it wants to self-destruct, okay? If it hears the shout, if it's within range of hearing the shout, it wants to self-destruct. So the way it does that is basically in here. First thing it does is it has some things that it sets up. It has to refer to the player to figure out how far away the player is. That's why it grabs it here. So in its start routine, it says, okay, the player is such and such. And then it adds its destroy me function to the on player shout broadcast. So we'll be listening for that on player shout. And the destroy me routine, all it does is start a coroutine, and the coroutine is the self-destruction coroutine. All right. Now we could, I suppose this could have been up and decide, okay, start the self-destruct coroutine if you're within earshot, but well, 601.5 doesn't have another. All of this, I guess, could have been in the, well, no, it's not a coroutine. So we had to start a coroutine because we have this yield in here. Anyway, all right, so destroy me starts a coroutine which does this. Checks to see, first off, am I within the hearing radius of this particular zombie? So can the player hear, or excuse me, can the zombie hear the player shout? So if hearing radius is 3 or 5, yeah, there it is. If its distance is smaller than that, then okay, I gotta get destroyed. So what I do is first off, I had a breakpoint waiting to happen there. First thing I did is I say, okay, I'm about to die, so I might as well remove my listener from the broadcast event, and then wait a random amount of time between 1 and 3 seconds for me to sort of explode. And I'm going to run this loop again. Each iteration of the loop is going to take, well, it's going to be timed to a 20th of a second. And so we'll say transform local scale, and we're going to interpolate from 1 up to 2, right? This is what's happening here, from 1 to 2. And this t is the length of time. So we know if it was just 1 second, it'd be I over 1, and so on and so forth. All right. So it does that, and then last but not least, it does this boom and destroys itself. So that's the basic zombie. Now, the moving zombie, we'll say convert carriage returns and line feeds. The moving zombie is a little bit more interesting. It inherits everything from the normal zombie, and on top of that, it adds this kind of random movement back and forth. So what it does is it first, during its start routine, it calls the base start routine, and then calls the random move. So randomly, every 1.5 seconds, it's going to decide to set its velocity to some value. It's kind of just shift it left or right, kind of lurch it around like a good zombie would. So That's what's going on there. And what else do we have? Oh, of course, we also have this switcher, which is the last bit of code. And the switcher part is really, really simple. What it basically does, it says, okay, if someone collides with the trigger that's on the switch, it then goes through all the sprite renderers that are attached to, or that are attached to any components or objects that are in this hierarchy, right? Because it has a little hierarchy. It has the switch, it has the graphic arrow, and it also has that little hazard graphic kind of thing. So it says for each sprite renderer foo in get components in children. So it means it gets it all in the children, everything in the tree. It just flips the x value. It says sets flip x to true or false depending on what it was. So it toggles that. And excuse me, last but not least, it also get component children. It gets the surface effector 2D and it swaps the speed of that so that it will change the direction of the surface effector. Okay, so not a huge amount of code. There's just those four little, you can stop the screen if you want to kind of check things out. And it demonstrates inheritance. So we have zombies inheriting from, or moving zombies inheriting from zombies. It shows interpolation, how we're interpolating the value between 0 and 1 or 0 and 3 or whatever it is, depending on how we want to blow up or shrink the player or the zombies. It demonstrates the delegates and events by having all of our zombie listeners waiting to hear the player shout. Some basic player movement. Adding forces, jumping according to physics. Oh, and of course, we also demonstrated our use of tile maps here, in that we had a deadly tile map for hazards. We had a normal platform tile map. Like in here, if we say platforms, that's using just a regular a regular tile map collider. It actually uses a composite collider on top of that to kind of even things out. This is not strictly necessary to put the composite collider on there, since we only have one tile map collider anyway, and we don't really have much reaction going on. So a tile map collider would have just done it anyway. So that's, we move around according to our tiles here, and then we have our hazards, which has our specific tile map with a collider and a deadly tag on it to figure out, should we blow up or should we die when we get there. So that's the basics. Hopefully that helps you with your projects. I better zoom in here a little bit so I can see what's going on. Let's help Shaggy come along. Oh, and that guy just switched. So we can, oh, yeah. Come on, zombies. Q. Nobody heard me shout there. All right. Q. And let's see if I can get more than one here. More bang for the buck here. Q. Nope. All right. Yeah, I can kind of fly. Whoops. Oh, I got him. All right. I'm good. I'm done.